just magnesium, and they're just showing it doesn't matter where you have the electrons. Okay, it has two valence electrons, they can go anywhere, just as long as they're not paired up. You do not pair them until you're forced to. Anybody that has kids knows if you can put them in a separate bedroom, you do. Because when you put them in the same bedroom, what happens? They fight. So give all the children their own bedroom until you're forced to pair them up. Okay? So, I want you to write the electron arrangement and the electron dot symbol for each one of these three. Chlorine, carbon, and phosphorus. Not on me. If you stop by my office door, you can take as many as you want. Good gracious. Look at all the empty spots on here. Look at this. There's as many people missing as there are actually here today, I think. So many people dropped on that. Where's Rodolfo at today? Anybody know him? No? Y'all don't know your classmates? Why not? Why not? You don't talk to each other outside of class? Ever? Why not? You don't study together?
Why not? Why not?
Why is a great question. When you lose the desire to ask why, then you probably lost the desire to live, in my opinion. You need to always ask why.
When I went to school 10 years ago here, everybody in my class they basically what their living room.
But you don't know anybody in the class, do you?
Not in any classes now because people have no need. They have the internet, they have the telephone.
Doesn't teach you how to solve problems, though.
You know, people don't talk to anybody no more. They go right to their phone. And they
Google everything. Sad.
don't sit around and talk about these.
Huh? I'll let you sneeze in there. You let me sneeze. All right. Chlorine. It's the electron arrangement. 2.
1. Oh, I just made it easier.
How many do we have? 17, right? 2 and 8 is 10. 7 more.
I was writing the electric dot symbol.
Well, it says to do both. So the first thing you do is write the arrangement so that you can figure out how many dots you need, right? 1, 2, 3, 4, 5, 6, 7. We already did carbon, right?
Yeah.
2, 4. Phosphorus. 2, 8, 5. 1, 2, 3, 4, 5. Everybody got that? We're all clear? We're all good? Happy? So far? Sure it is. It can be. Why does it have to be hard? Oh, before we go on with atomic science, who's aggravated with the follow-up assignments? Anybody? Why are you aggravated with follow-up assignments?
I don't find them helpful at all because I don't understand what I'm doing wrong to begin with. And when they just go through the same steps, I don't see.
That's what it's trying to do. It's trying to lead you through step by step some of the topics that you did poorly on the other problems. That's what it's doing.
Right.
So you don't think that going step by step through those problems is helpful? Or
Me,
I feel like I'm being picked on.
because I don't really know.
somebody
Yeah,
last
you're not
class said
even
that too.
if you need a little bit extra, that gray area, you need some gray area. It's either black or white, but you need a little bit more information to help you get to that next.
I feel
Line
like
moment,
some of
ADD
my
moment, like
problem
ADD.
is, I don't know what equations are appropriate for what they're asking. So,
Okay.
if I don't understand what they're asking in the first place, I don't know what to do.
Well, then what we need to do is you need to come see me and we need to talk about how your problem solving skills is what you're struggling with then,
Okay.
and figuring out exactly what each one of them is asking. So it's not, if you knew what they're asking, you might be able to solve them. Is that what you're saying?
Yes.
So we need to work on that some. So once you come see me a couple of times, we'll work on that for you. But yeah, the follow-up assignments aren't intended to pick on you. They're intended to say, hey, these are the sections that you didn't do well. Let's give you some step-by-step problems to help you figure out how to do this style of problem. I know it feels like you're being picked on, but you're not. Okay, atomic size. Do it.
I said, I'm not used to this learning style using computers. This is all new to me. It's taking some adjustment.
It will take an adjustment, but it's something, think about it this way. It's a technique that 20 years ago, 10 years ago, I could not have ever even thought about doing. It personalizes each one to you. So if everybody in this class had to do the follow-up assignment, every one of them would be different. That's amazing that it can do that. I mean, in my opinion, I couldn't look at everybody's homework and decide I'm not that good. I might be able to say, well, you might need to work on this section. You probably need to work on this section. You know, I could maybe do that. But there's no way I could design a specific homework set just for each one, each person. That's beyond my ability. It's something you have to do with the computer. It has a formula in there that uses to calculate that. All right, atomic size. What are we talking about with atomic size? We're talking about, when you think about an atom, most people think about an atom as being like a ball, right? What are we talking? Relative to each other, some atoms might be ping pong balls and some might be beach balls. Some might be softballs in between, right? Fair enough? Well, how big are these atoms relative to each other? Is the question. Atoms are really tiny, okay? So they're not really that big. But compared to each other, the size changes, okay? So the size changes on the periodic table as it increases as it goes from top to bottom on the periodic table. Anybody want to give me a guess as to why the atomic size gets bigger as we go down the periodic table? Which one? But the number of protons doesn't change how big the atom is, does it? It's really the number of electrons gets bigger and bigger. And because you add more and more electrons, what do you have to have? You have to have more and more energy levels, right? So as you go down on the periodic table, you add, every time you go down another row, you add another energy level. You go up another floor in the apartment building, right? So the atoms get bigger and bigger. So if we look at the alkali metals on your periodic table, hydrogen doesn't count. So we look at lithium, and we go from lithium down to francium, right? Francium's in the bottom left corner. Fair enough? The size goes from relatively small with lithium, only 2 energy levels, up to this gigantic beach ball of francium, 7 energy levels. Okay? That's easy, huh? Now, so that's top to bottom on the periodic table. Things get bigger. What about when you move from left to right on the periodic table? What happens? When you go from left to right, they get smaller. Atomic size decreases as you go from left to right. Now I'm going to draw a picture to help explain that. I think I can do it.